All right. Hi, everybody. I'm Alex Marangon. I'm a senior engineer at DigitalOcean, and I work as part of the storage systems team. So our role in the storage systems team is to handle the entire lifecycle from deployment to decommission of all the storage backends at DO. Um, as you may already know, DigitalOcean is a large Ceph consumer. We are also part of the Ceph Foundation, and we haven't really done any public talk about our use case, and so this is what it is about today. It's going to be fairly superficial. We are only just going to brush kind of the surface about what we do with Ceph and how we operate it and whatnot. The goal is that the world will hopefully be in a better place in 2022. And so for the next Cephalocon, if it happens, we'll be able to present some talks with some more deep dive on our use cases and how we use Ceph. But today, yeah, we're going to keep it more as an introduction of how we use Ceph at DO. So in terms of agenda, we're going to start with what's DigitalOcean in case you don't know the company. And then we're going to dive straight in with Ceph at DO, just presenting some statistics and the products that use Ceph over here. And then when I was building the talk, I was really thinking, hey, what should I talk about? And I figured I would talk about operation, how we operate Ceph, the kind of processes we have set up, and the automation we have developed around Ceph, and a few issues that we've noticed. I call it Ceph gripes. It's not a good term, and it's not a blame game. It's just some stuff we noticed that you may want to put in your radar if you start to have to deploy Ceph at some scale. And that should take us at around 40-45 minutes of me talking, which will leave us plenty of time for any questions you may have. All right, what's DigitalOcean? So very briefly, DigitalOcean is a cloud provider that was founded in 2012. And the core concept of DO is simplicity. It's simple to provision cloud resources. The UI is simple. It's simple to sign up. The pricing is simple and all of that. So that's really the core concept of DigitalOcean. The first product that was released is called a Droplet, which is what we called a virtual machine. And the main attractivity of this product at the time was that every single droplet came with a local SSD attached. Even your $5 droplet did come with that in 2012, which was extremely attractive, and it's really what put DO on the map as a resource provider at the time. Since then, we've expanded our product portfolio, starting with volumes, block storage in 2016, and many more products have been added since, including Spaces, which is our object S3 storage platform. But if you go onto the website, you'll see many more products such as managed databases, managed Kubernetes, one-click app deployment, and a lot of other very cool stuff. In terms of global footprint, we have data centers in 8 regions, with each region having multiple data centers as well. And in terms of lifecycle of the company, one very important event happened about 6 months ago with our IPO earlier this year. All right, so let's talk about Ceph at DO. So in terms of footprints, we use DO for 2 products, block and object. So block is what we call volume, object, the name of the product is Spaces, and they are both backed by Ceph. We have a third storage product in our portfolio that's called image backups, or bring your own image, that today is not stored in Ceph, but that is something that we are looking into, and we hope to start to make it part of Ceph next year, early next year. In terms of number of clusters, we have a total of 38 production cluster on Ceph, 38 production cluster. 37 of them are on Ceph Nolus, and 1 is on Ceph Luminous. This laggard is simply due to the fact that for block cluster, we've decided to repave all the OSDs from Firestore to Bluestore before the upgrade. And so we have 1 laggard in that that should be finished very soon. So at the end of next month, we'll probably have all of our cluster on Nodus. The entire repave process was over 3,000 OSDs, so it took a bit of time. In terms of actual usage, we have over 54 petabytes of raw Ceph storage, and that represents around 21,500 OSDs. For hardware, block storage is and has always been all flash, 3x replicated. Object storage is a mix. We have a mix of HDDs and QLC flash for newer object storage clusters. And they are pretty much all, except for some specific cases, they are pretty much all using Erasure coding with 5.2 and 4.2 KM values. The index nodes are obviously all flash and have always been all flash as well. So why did we pick Ceph? So Ceph was selected way before I joined DO. We started with it in 2016. I joined in 2018. But the reason why we picked Ceph are pretty much the same reason you see in marketing documents about Ceph. The scalability, especially the ability to add nodes horizontally, that is very straightforward to do and quite safe to do with the right set of processes. So we can expand the size of our cluster very easily. The most important point in all of this to me is the reliability. And that goes via self-healing and the strong consistency that comes with Ceph. We've had situations where something went wrong in our cluster and we had an outage, and you can see your PGs being in terrible state. They are down, incomplete, stuck peering, and what have you. But every time we solved the underlying issues that caused this outage, Ceph came back on its own with very little to no intervention. And that is a huge, huge, huge strong point of Ceph. We don't have to intervene a lot. There's obviously also the scrubbing and auto repair that is fairly cool to have. In terms of performance, we always want more performance, and if you give us more performance, we're not going to complain about it. And if you look at the Ceph survey every year, performance and asking for more performance is one of the top items. But generally speaking, Ceph performance has been very much acceptable. We don't have many issues related to Ceph performance. It is what it is, and it is quite good as is. We always want more, of course, but it is acceptable. And although it does not scale perfectly linearly, and we cannot expect that to happen, it scales linearly enough to the point where we can really predict the performance of a cluster from its size, which is a fairly nice concept and improves our operation quite a lot. Obviously, it works with all the shelf components, so no appliances. That is a big win. That does mean that when you deploy new hardware, you need to do more testing. And when you upgrade your OS, you need to do more testing. But we are not tied to any appliances, which is a big win. And also very importantly to us, it works with multiple products. As I said, we use it for object and block storage. And the ability to have only one backend greatly simplifies our lives. We only have to have one set of automation. We have to deep dive into terms of knowledge into one product and not multiple. So that means that we can handle more cluster with less people and less automation. And that is obviously a huge win for us. All right, so let's talk about Ceph operations. So what we do in terms of operations, that's going to be, I've selected a few items to talk about. We're going to brush the surface, but we do some fairly cool stuff, and I'm going to introduce a couple of open source tools that we've developed that might be of interest to the community. So one of the core concepts of our team is that we should not scale the number of people we have in the team with the number of clusters. That would be pretty bad. So our goal today is to automate as much as possible with a final perfect goal to never have to SSH into a machine. We're not quite there yet, but maybe someday. In terms of operation and automation, it is mostly done via Ansible playbooks and AWX. AWX is the open source version of Ansible Tower, which I think now is named Red Hat Tower. And we still do have some standalone tooling left here and there that we will want to turn into service in the near future. But for now, standalone tooling that works pretty well. All right, so in terms of deployments, nothing really exceptional going on there. We have our own in-house Ansible playbook to deploy Ceph in containers. So we started containerizing Ceph as we upgraded from Luminous to Nullius. Instead of just upgrading the package, we do a containerization of the daemon, and every new cluster that is deployed is containerized. We don't use Ceph ADM for the simple reason that on Nullius it's not available. When we go to Octopus, or pardon me, when you go to Pacific, we may evaluate Ceph ADM, but for now, we have no plan on switching to it. So what we do in terms of deployments, we build our own Ceph packages because we cherry pick a lot of patches instead of upgrading Ceph directly. This lowers the risk of an upgrade going wrong. More on that in a bit. And in terms of daemon we use, we basically use the Ceph daemon base image, which is just the image with installed packages. And we have just a minimal script to mount OSD outputs. That's like 15 lines of bash. That's fairly straightforward. In terms of operation, it's very nice to have all your OSD in a sequential order when you use Ceph, because if you see an alert that says, oh, OSD 012 have slow request, you know that the OSD 012 are in the same host, and you know that you have something to investigate on the host. But deploying it that way is super slow. Like it's going to take 8 to 10 hours because you need to deploy all the OSD one by one sequentially. So a neat trick we applied is that because we know how many OSDs we're going to have per host, instead of deploying one at a time, we just pre-create the crush map before the deployment, and then we can deploy all the OSD at a time. And so, yeah, that's one of the things we do. And one of the other reasons why we have our own in-house Ansible playbook to deploy Ceph instead of using something like Ceph Ansible or something else available within the community is because we have a tight integration with our secret management platform that will push the Ceph configuration, some secrets for monitoring, and some third-party services that need to access Ceph, or the hypervisor queuing to our secret management platform for later integration. So all this combination allows us to reduce the time to deploy a cluster from, it used to be like a couple of days with a lot of manual tasks to now maybe half a day to deploy a new cluster. In the future, our main goal for automation is to do a zero intervention deployment where the hardware becomes ready from our infrastructure team and Ceph automatically deploys without us doing anything. We just have a Slack message or something that tells us, hey, Ceph is deploying there, and we just let it go. In terms of monitoring, we use, for monitoring Ceph health and Ceph status in general, and like the global information about our Ceph cluster, like capacity and all of that, we use Ceph Exporter, which is an open source Prometheus exporter that we developed. We don't use the exporter that is part of the Ceph Manager module for a couple of reasons. The first one is when we started Ceph, it was simply not available and we needed something. So we created Ceph Exporter. And because we created it and it's working very well for us, we haven't really thought about moving to the Manager one. But we also have some, I believe, justified concern about the Manager's scalability. We noticed last week as we upgraded one of our clusters to Nullius that the Manager is struggling to keep up because of what I suppose, and we are starting the investigations this week, so we're going to report that back to community when we know exactly what happens. But we think that it's the support module that struggles to keep up with data, and it's basically overloading the Manager. And the problem with the Manager today is that it doesn't scale because it's a single process. So the only way to scale it would be to put it onto a more powerful machine, which is obviously very expensive. So we're going to look into that this week and report that back upstream to see what can be done. But yeah, we're looking into that. In terms of other monitoring, we have Node Exporter running. That's the open source Prometheus exporter, so not much to say there. And we also have built another exporter called Store Exporter that is used to gather information from every single daemon in the cluster via the admin socket. So cool stuff, for instance, that we discovered through it was Blue Store allocated versus Blue Store stored. That showed us the overhead of the minimum allocation size on Luminous with Blue Stores. That was 64K for HDDs with Luminous. That since has been switched to 16K on Nautilus. But we saw that overhead, and based off that, we decided to do some testing on 16K minimum allocation size on Luminous, and we found out that it worked very well. So we actually switched to that. It also exports other information. Most notably, something we noticed and we haven't investigated yet is that with Ceph Nautilus, it seems like the slow requests that are reported to the monitor might be undercounted. So we export the slow request directly from each OSD admin socket instead now, and we aggregate that into a graph and a dashboard. But yeah, we need to look at this though at some point in the very near future. And other monitoring, we have a canary process that is running regularly on each cluster to check performance and availability. So to take block as an example, it's going to run read and write workload with different block sizes regularly on our cluster. And that gives us two sets of data. Either it times out, and that means we have a big availability problem on our cluster, or it doesn't, and that gives us a trend line of the performance of the cluster over time. And that's always interesting to see when you upgrade or when you do an operation to see the impact of latency that it has on our customers. So when we upgraded to Nautilus on the cluster, it was very cool to see that after restarting all the OSD, we saw the average latency decrease a lot, and that was fairly cool. In terms of other Ceph operation, Augmenting Ceph is easy, but it's still something where you can shoot yourself in the foot if you're not careful. So we have two ways to augment Ceph today, which is not optimal. We want to converge them both, but we haven't got to that yet. So from the block cluster perspective, it's pretty much the same thing that you're going to see out there in the mailing list or on IRC, where people are recommending how to augment safely. So we create all the OSD in a dummy root tree with a weight of zeros, and we move these hosts to the right crush location in the right racks, and we slowly upweight them to avoid any latency issue, right? If you just add everything at once, you're going to have latency issue on the clusters that's going to impact customers. The only difference with what's usually recommended upstream is that we actually have developed a tool that automatically does the upweight for you at a specified interval. So by default, we automatically upweight by 0.2, I believe, until we reach the weight we want to be at. So the tool is open source. It's available. It's called Archimedes, and it will automatically handle this crush upweight for you up to the weight you want it to be. From the object point of view, we have a different process that is more interesting process-wise, I think. So the way we do augment is we're going to set no backfill, no rebalance to avoid any data movement. We create all the OSD in the right location with their final crush weight. So you see a lot of peering happening at this stage, and a bunch of PG are going to switch to backfill state. But nothing is going to move. Then we cancel all the backfills via via upmap overwrites. So if you had a PG that was like 012, you add your OSD, it became 013, we switch it back to 012. So that means that all your PGs are going to be back to active plus clean, like nothing happened. To do these upmaps, we use a tool called pgremapper. More on that in the next slide. So because all the PG are active plus clean, we unset no backfill and no rebalance, and nothing happens. And the way we actually perform the augment is two ways. Either we're going to run the Ceph balancer in upmap mode, and because the Ceph balancer, we always try to undo upmap before it adds a new one. It basically do our augment for us. But the concurrency of the upmap balancer is pretty low, and we don't want to change it because we use it for the entire cluster. So it's like 10 PG at a time. If we are on a rush for the augments, we can use pgremapper, which has an undo upmap function that allows us to undo upmap on a set of OSDs with a specified concurrency. Why do we do the augments this way when an augment in object is not latency sensitive? Is to protect us against long-term degradation. In object cluster and HDDs, even if you're on BlueStore, you're always going to have some sort of flapping. It's just going to happen. If you have all your backfill going on and you have flapping in someplace else, your PG from the flapping are going to need to recover, but some of them are going to be recovery weights and blocked by the backfill reservation taken from the ongoing backfill. And so they're going to be degraded for a bit. And then you're going to have another flapping, which is going to trigger more degradation, and so on until the augment is finished, and then the recovery is going to go away. That means that your degradation can be very, very long lasting, and that's quite uncomfortable. By doing this process where we only undo a certain amount of upmaps at a time, we lower the time to degradation. So let's say we only undo 10 upmap at a time, that's 10 backfilling PG. Once they're done, whatever recovery needs to be done can be done, and then we start again and again and again and again. So limiting the time to the time you're being degraded. So both approaches are basically either limit impact of latency or limit the risk of data loss due to long-lasting degradation. So pgremapper. pgremapper is a tool we open sourced about 3-4 months ago, so fairly recently, that is heavily inspired by a set of CERN scripts that I believe mostly Dan Vendester wrote. So I put both URLs there, of course. pgremapper is in Python, is in Golang, and upmap scripts from CERN are in Python. In terms of ability from pgremapper, it allows you to cancel backfill for augment, like I just described, or prioritize recovery weight PGs. We also use it in block. We still have a bunch of file store block clusters, well, mostly file store. It's mixed now. And so when we recreate, a new OSD, there is flapping going on. So we can recreate the OSD, cancel its backfills because the cluster goes back to active plus clean, and then do it like 10 at a time to not prevent recovery from happening in another part of the system. It allows you to undo upmaps. I already talked about that. It allows you also to balance a crush bucket, which is similar to the functionality you have with the upmap balancer upstream, except it's localized to a specific part of your system. So the upmap balancer can do on a per pool basis. Here you can do on a per crush bucket basis. It doesn't have the same complex considerations that the upmap balancer has. I think, if I recall correctly, that I might be wrong, but I believe it just looks at the PG distribution. So it's just going to try to equalize the number of PG you have in your buckets, in your OSD pairs of buckets, which work in most cases, but doesn't take into account crush weights and doesn't take into account if you have a non-power of 2 pool and all that. It also allows you to drain an OSD, which is a process we've used when we repaved our file store cluster to BlueStore. We drain the OSD, which is like marking it out, but only much more controlled, because we don't do 100 and 200 PG at a time. We only do it 10 or something at a time, which limits the impact of latency. It allows you to remap PG, which is kind of a wrapper around the Ceph CLI for the same thing, to create an upmap exception. And finally, it allows you to export and import mappings, which can be useful in your automation. It was to us for the draining and the file store recognition, because if you have upmap exceptions but you destroy the OSD, the map exception are going to be removed from the OSD map, rightfully so. So you can export them before you destroy and then re-import them back to avoid having to rewrite them. So yeah, check it out, DigitalOcean/pgremapper. And if you have any issue with submit, and we'll try to fix it as fast as possible. In terms of OSD Lifecycle, we've developed a single tool, basically to handle the entire OSD lifecycle from end to end. So we have these tools that allows us to diagnose, recondition, deploy, upgrade firmware, remove from the cluster, and locate OSD and blink the light on our chassis for the OSDs. Most of the operations that are Ceph-based, like remove, create, and recondition, just wraps around Ceph volume. It also wraps around Ceph disk because we still have one file store cluster, so that's code we're going to remove soon, but not yet. But in terms of cool feature, I think one of the cool one is really the ability to automatically upgrade the firmware. So it used to be, from a operational point of view, when you need to upgrade the firmware, you replace a drive, it's taken from a pile of spares, you put the spare in the machine, you look at the firmware, you then look at what is the latest version of firmware we have validated, and if it's not matching, you upgrade the firmware. Now what it does is we replace the drive in the machine, and when we run the command to deploy the OSD, it automatically, before deploying the OSD, checks the firmware, fetch the latest version, run the firmware upgrade, and then actually do the Ceph OSD deploy. So from our operational point of view, it's a huge gain of time. Similarly, when an OSD goes down in Ceph, we need to determine whether this drive needs to be replaced or not. And it used to be a very manual and tedious process where you log into the machine, you look at the log in a couple of different places, and then you make a determination. And that was just a pain. So we developed a diagnostic tooling as part of this tool that's going to look at smart data, syslog, maybe some NVMe stuff, I don't recall. But basically, it's going to make a determination on whether a disk needs to be physically replaced or not. And if it does, we just swap the drive and redeploy the OSD fairly quickly. This diagnostic tool is probably, it's not as mature as we want it to be, but as we have more different type of failure, we just add more and more and more and more data to it. The long-term goal for this tool is to turn it into a service, so that unless we have to swap the drive, we never actually log into the machine, which would be very, very sweet. And finally, in terms of automatic remediation, there are issues in Ceph that are recurring, but not really, don't really have an impact. A typical example of that is the Ceph manager that is running out of memory. It doesn't happen often, but because we have 38 production cluster, it used to happen maybe 3-4 times a day in global. And it's running out of memory, but a simple restart fixes it. So we haven't really invested any time or resources into looking into why that happens and to try to fix it, because the fix is so simple and it's not impactful that we just have other priorities. So we have this automatic remediation service today that's going to monitor every cluster in our fleet, and it's going to look for condition. So in the case of Ceph Manager, it can look at, hey, how much memory is being consumed by the Ceph Manager process? And if it's over X gigabytes, I don't remember the number, we trigger an AWX job, which is an Ansible playbook, to fix it. So in the case of a manager, hey, the manager is over that amount of memory used, just run a playbook to fix it, which is just restart it. And that dramatically reduces the number of alerts we have for this and the intervention from our cloud operations team. It used to be the same thing where we have a page for our cloud operation team, they log into the machine, restart the daemon, and then come back. And it used to be 3-4 times a day, which is a huge pain in the ass. So we have this automatic remediation service in place to do that, and we plan to add more stuff to it as time goes. All right. That's it for Ceph operation. Again, brushing the surface, and I really hope we can deep dive more into that in person at the next Ceph Alcon. We'll have some fun. Now, in terms of Ceph gripes, again, it's not blaming. It's stuff we notice that you may want to be aware of for specific scenarios, and also it's stuff that we are looking at or plan to look at very soon. So the first one is that Ceph upgrades are hard, and we learned that with Nautilus. The process is simple, but there are many issues. The process has always been the same. I've been using Ceph since slightly before Argonaut, and it's always been the same process, and that's very cool. You upgrade your mon, now you upgrade your manager, your OSDs, and whatever clients you may have, right? It's always the same. And sometimes you have some short intervals, like you need to add something in a set.conf and all of that, but it's never, this part is always very well documented. But you always have some small issue popping up that are not very well documented, and the documentation during upgrade is actually somewhat sparse. And that's a difficult problem to solve, right? You cannot expect engineers every time to be like, oh, I need to document that and that and that. That just never works. And we know that. To give a couple of examples of sparse documentation, a very simple thing was from Luminous to Nautilus, the output of the JSON output of Ceph PG dump changed, which broke any tooling that would have used that. And that was not documented. So it's not a big deal in the sense that we caught it very early before we even upgraded and we fixed all of our tooling. But it does point to the fact that it's lacking in documentation, and if such a change is not documented, it means that a lot of other small things are not documented. Another thing that changed for us that we didn't find the documentation for was with Nautilus, the Ceph OSD process will now by default disable transparent huge pages, which is a change from the default of the operating system, which actually caused issue for our file store HDDs. So we fixed that, and we changed the configuration, but again, it goes back to documentation. Upgrades can be slow. It's just a fact of life. When there is on-disk check or changes during upgrade, it's just going to be slow. But it's important to know when you plan your upgrade, never plan an upgrade of a cluster with HDDs at 2 p.m. because you're going to be there for a while. So yeah, privilege the morning. One thing that is important as well is that the history of the cluster matters a whole lot. We've seen that very recently with a message on the mailing list stating that if you created your cluster prior to Joule and have never used CephFS, you need to stop at a specific version of Octopus before going to Pacific. And that happens. That's okay. It's not a complaint about these specific things. It's just a statement that the history of the cluster matters a whole lot. And so that makes upgrades even more complex, because how can you have proper testing if the history of the cluster matters when staging systems are not meant to be long-lived systems, right? They're meant to be recreated a lot. So that's something we're trying to think about. And something else we learned the very hard way earlier this month, about 2 weeks ago, is that a successful upgrade does absolutely not make a trend. We upgraded 37 clusters recently. 30, I'm rounding up or down, doesn't matter, but about 30 of them went completely uneventful, where nobody who knew the cluster was upgrading could tell the cluster were upgrading. So that was fantastic. On some block cluster, we saw issues. We hit a bug where all of our PG went into Snapstream, which was scary because it looked like it tried to replace the entire Snapstream history of the cluster. And so the first time it happened, it wasn't a huge impact. We were able to set no Snapstream and disable Snapstream and then schedule our Snapstream slowly and surely. And we updated our automation for it to not be impactful on further upgrades. And it worked for some clusters until we upgraded our last 2 clusters, and that did not work. And there were so many Snapstreams that the entire cluster started to flap all over. The OSD started to spam the monitor with the OSD logs, which makes the monitors completely unresponsive. And so that goes back to the point that, yeah, a successful upgrade does not make a trend. And so all of these points here means that testing upgrades and testing Ceph in general is extremely difficult, and that is an extremely complicated problem to solve. And we're not saying, hey, community, fix that, please, and going away and just waiting for it to happen. We are going to look at that very, very, very closely as we start to look at Pacific within the next weeks, months. I don't know exactly when we're going to start, but we're going to start very soon. And as we look at that, we have to look at how we improve testing for Ceph and how we improve reporting our issues upstream, and maybe some collaboration for the testing part with upstream. So we're not sure how it's going to look like, but we're definitely going to try to improve that for everybody. And the last thing in terms of gripes I wanted to mention is around RGW defaults. If you're using the RGW at a certain scale, you may want to be wary of a few things that I mentioned here. Dynamic resharding. The naming I found a bit unfortunate because it doesn't. It's not clear that dynamic resharding is going to block writes on your buckets. And you can see that in the mailing list with a lot of people saying, hey, I have resharding going on and I can make IO. It works well up to a certain stage because in most cases, if you have small buckets, dynamic resharding is only going to take a few seconds or up to a minute, which is fine to block writes for a minute. It's not going to cause anything. If you have a very, 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 very large bucket that you're resharding, the reshard could take hours, like 10 hours easily, if you have a humongously large bucket. What happens during that time is the write requests going to that bucket are going to be blocked on the Rails gateway, which is going to take up threads. And they are never going to be timed out on the Rails gateway. They're going to stay there indefinitely. Your clients, however, are going to time out and they are going to retry the request and retry and retry and retry and retry. And as I do that, they are going to take more and more and more threads on your Rails gateway until they possibly exhaust all the threads available, which means that no other request can go through to the cluster. So if you're using dynamic resharding and you plan on having very, very, very large buckets, be wary of that. Another thing, another consequence of resharding in general is that it makes listing very expensive on the back end, way more IO, and slower on the front end. So something to be aware of. Beast on Nodus has a couple of issues. The first thing you want to do if you use Beast is you want to set SOMAXCon. I think Canonical made a patch for that. You can set that as an option. I think it's MaxCon. In the configuration option, you want to make that to your SOMAXCon on your system, or even increase your SOMAXCon on your system and then set that to that. Because otherwise, you cannot send a lot of concurrent operation to it with the default thread settings. One important thing to know, and this is on Nodus, I know Octopus and Pacific have improved that. I don't know the final status in Pacific, so I'm only talking Nodus here, but most of the liberators call, even though Beast is asynchronous, most of the liberators call are not. They are still synchronous. So if you are in a situation where your cluster has some sort of issue and you have a few slow ups on your cluster, you may exhaust the thread on this very quickly because it has a very small amount of threads by default. I think 500, 512 maybe. So you may exhaust that and actually prevent any further requests coming through because of it. We found in our testing that this performed extremely well, like impressively well compared to Seabed Web in normal cluster condition. But when we have this type of issues, not so much. So we try to increase the number of threads in Beast and do some testing there. But increasing the number of threads in Beast does not scale as well as increasing the number of threads on Seabed Web. So for that reason, we are actually now running Seabed Web on Nautilus in our cluster. As we look towards Pacific, we are definitely going to look at Beast again and see if things have improved there. And the last thing I wanted to mention was auto shard removal. That shouldn't be an issue in 99% of the cases, but at some point in Luminous, a patch was added to automatically remove the shard. So if you run dynamic resharding, or if you don't run the RAS gateway admin command for resharding, it used to leave the old shards behind and you had to manually remove them. Now it does it automatically. However, if you do it on a very large bucket, you may dust your cluster because the operation to delete is just a readless delete of the object. And if it has billions of keys, it's gonna dust your cluster by virtue of just preventing the OSDs that have the free replica of it from contacting the cluster, and that you're gonna go down for a bit. So the way we do it is that we develop a small tooling that using Ceph that just iterate over the key and delete at a specific amount of time. I think we delete like 10,000 entry at a time every few seconds and just catch up until it's done, and then we remove the object outright. All right, that's all I have. As I mentioned, very superficial. I really hope we can talk more at Cephalocon next year. I really hope we can do that. Before any question, just wanted to mention we're hiring. We've backfilled a couple of jobs already in the storage systems team, but there are other jobs out there for DO with Ceph and without Ceph, like in Kubernetes and whatnot. So if you're interested, have a look at do.co/jobs. I'm trying to maintain the list of jobs in the Ceph jobs pad as well. Yeah, I'll try to do my best on that. And if you don't see a job that you like, or if you have any question after this talk that you think about, please do feel free to shoot me an email, amarangan@digitalocean.com. And if you have any questions, I'm happy to answer them. All right, well, I'm going to take that as no questions. So I guess that's it. Thank you very much, everybody, for joining, and have a good day.
Yeah, just a second, Alex. Can we get the slides?
Sorry, what was that?
Thanks. Can we get the slides?
Yes. So I'll send them to Mike, and I'm sure he has like a platform to share them. I'm not sure, but I'll send them to Mike to see if we can share it.
Okay, thank you.
Absolutely. All right. Thanks, everybody. Have a good day.